In this video, we are going to use transformations to graph the following function. And what we first want to notice and identify is the parent function that is to be transformed. And we can see that y is equal to 1 over x is the beginning function that we start with, and then we use transformations to get this f of x function. Now, we can see that we have some shifting here. We've got a left 1 shift and a down 2 shift, but this 2 in the numerator here is going to be a stretch, a vertical stretch, which is a little bit harder to notice in its current position. But if we rewrite f at x as, instead of 2 over x plus 1, we could write that as 2 times 1 over x plus 1. And if we rewrite it in this way, it's a little bit easier to see that this 2 is on the outside, which is going to imply that it's a vertical transformation, and specifically it's going to be a vertical stretch where we manipulate the y values of the ordered pairs in a logical way. So we're going to be multiplying each y value by 2. As a reminder, the order of operations for transformations is that the first thing that we do is deal with all the multipliers, whether that is a multiplier of a 2 or a multiplier of a -1 that would give us a reflection. And then after we perform the transformations that we get from multipliers, that's when we're going to then do the shifting that comes from the adding and subtracting. So the first thing that we want to remember is what the parent function looks like. So this reciprocal function is going to have asymptotes, a horizontal asymptote at y is equal to 0, but as well a vertical asymptote at x is equal to 0. And then the points of interest that we want to keep track of as we do our transformations are going to be the ordered pairs 1, 1 and the ordered pair -1, -1. And our graph, this reciprocal function, is going to approach the asymptotes, pass through those points of interest, and then approach the asymptote and pass through the points of interest. We can also keep track of our points of interest here by looking at them in a table. So our 1, 1, our -1, -1 point, we can also put our asymptote equations in here and keep track of where those land with every transformation. Now, our first transformation is going to be the multiplier. So the first thing that we're going to do is get the graph of y is equal to, we could either call this 2 over x, or we could call this 2 times 1 over x. However you want to think about that, either of those are fine. In the interest of space, I'm going to call it 2 over x, and then we'll just make note of the fact that in order to apply this transformation, since it's an outside multiplier, we're going to multiply the y values by 2. So that's going to make our ordered pairs 1, 2, -1, -2. Since x is equal to 0 is an x value, we're not going to do anything to this. And y is equal to 0, this is a y value, so we do actually multiply it by 2, but it doesn't change the equation of the asymptote when we multiply 0 by 2. So it turns out with this transformation, neither one of the asymptotes actually changed. So the way that plays out on the graph over here is that our x-axis, or the equation y is equal to 0, as our horizontal asymptote does not change. The vertical asymptote also didn't change, right? When we multiply the y values by 2, neither one of these asymptotes changed. What did change is the points of interest in the first and third quadrant. This ordered pair vertically stretched up to a new point that was 1, +2, and then this ordered pair vertically stretched down to a new ordered pair, which was -1, -2. And now we connect these dots with a graph that is approaching the asymptote, has been vertically stretched, passing through that point, and approaches that asymptote. So this is the result of our first transformation. So back over here, we have taken care of the multipliers. So now we're going to perform the transformations that result from adding and subtracting, and those are going to be our shifts. And the shifts can go in any order, so I'm just going to perform the inside shift first, this is going to be a shift to the left 1 unit. When it's inside, the transformation is horizontal, and it's backwards from our logical brain, backwards from what we would think we're going to do. So because we have a +1, we actually go to the left 1 unit there. So let's come back over here to our table. The equation that we're going to be graphing now is starting from the vertical stretch. We've already done the vertical stretch. Now we're just going to shift everything to the left 1 unit. So this will be our new equation, and we come up with these ordered pairs by manipulating the x values in a backwards from logic way. So we're going to actually subtract. It looks like we would be adding 1 to the x values, right? But because it's inside, we are actually going to be subtracting 1 from the x values in order to achieve the new ordered pairs after we have performed this transformation. So we subtract 1 from the x values. So this first ordered pair, if I subtract 1 from the x, I'm going to end up with 0, 2. The second ordered pair, if I subtract 1 from the x, I'm going to get -2, -2. Remember, we don't do anything to the y values when we are manipulating the x values. So now we have an asymptote that has an x coordinate. So because this is an x coordinate here, we are going to subtract 1 from that x value. But with the y equals 0, we don't do anything to the y values, so this asymptote is not going to change. So we're just going to keep that at y is equal to 0, because the only thing we do is subtract 1 from x values. So over here on the graph, when we subtract 1 from these x values, we're basically going to be moving everything to the left 1 unit. Our subtract 1 from the x's and subtract 1 from the x's, we could think about it on the graph as well. When we subtract 1 from this x value, we're going to move this asymptote over to the left. So my new horizontal or vertical asymptote is now situated at the x coordinate -1. But when we subtracted 1 from the x values, that didn't affect the horizontal asymptote. Moving it to the left does not change the horizontal asymptote. But moving this ordered pair to the left 1 unit is going to take me to the new ordered pair 0, 2. So we have the point 0, 2 on this graph. And then if we move this second ordered pair to the left 1, or subtract 1 from the x values, what we can see is that we move to the new ordered pair -2, -2. So let's plot that over here. So we've moved everything over to the left 1. Now we'll connect the dots and approach the asymptotes. We approach the vertical asymptote x is equal to -1 and the horizontal asymptote y is equal to 0. Approach the horizontal, pass through the point, and approach the vertical asymptote over here. So now what we see is that we have completed the vertical stretch. We've moved it to the left 1, and the last thing that we need to do is now move the entire thing down 2 units. Because this -2 is on the outside, that's going to be a vertical transformation. We're going to manipulate the y values of the ordered pairs in a logical way, right? So if we see a -2, we're literally going to subtract 2 from each of the y values in the ordered pairs. So we can keep track of the points of interest either in the table or on the graph. I'm going to do both, right? So I'm going to start with the table. So 2 over x plus 1, we've already done those transformations. The last thing we're going to do is subtract 2 from the whole thing, which basically means that we subtract 2 from the y values of each of the ordered pairs. So for our first ordered pair, if we subtract 2 from the y value, we're going to get 0, 0. Remember, when we manipulate the y value, we're not going to change the x value at all. So no change to the x, but we subtract 2 from the y, so that gives me -2, 4. No change to the x, so that means that I'm going to keep the x equals -1 vertical asymptote. This is a down 2 shift, right? So the vertical asymptote doesn't change, but we do change the y values. We do subtract 2 from the y values, so that is going to change my horizontal asymptote. I am going to subtract 2 from this y coordinate. So over here on the graph, what we're going to do is subtract 2 from each of the y values. We subtract 2 from the y value here, but we don't change the x coordinate at all. When we manipulate the y values, we don't change the x values, so all of these are going to change, but not any of the x's. So let's start with the horizontal asymptote. We subtract 2 from that y value, and we end up with a new horizontal asymptote at the horizontal line, y is equal to -2. We do need to label everything. The vertical asymptote is not going to change with the down 2 shift, right? So we just keep the same x is equal to -1 vertical asymptote. And then we're going to shift each of the ordered pairs down 2, and again that is obtained by subtracting 2 from the y value, not changing the x. So this one goes down to 0, 0 right here. And then this ordered pair, when we subtract 2 from the y values here, that one's going to go down to -2, -4. So we have -2, -4. And then now we just need to connect our dots. We'll approach the asymptotes, pass through these ordered pairs, and approach the horizontal. So we approach the vertical and the horizontal, approach the horizontal, approach the vertical, pass through the point. And this is our final answer because that was the last transformation. And then we can actually check our answer on our graph. So from the home screen, we're going to click y equals. We'll plug in the equation. I prefer to use alpha f1 to get my numerator denominators. 2 over x plus 1 in the denominator here, and then -2 on the outside. So then we hit our graph button, and so far it looks like we're in the right spot, but we do want to check our ordered pairs, so we say second calculate value, and we plug in the x coordinate of our points of interest, so we see that that ordered pair is in the right spot, and we also want to plug in -2, which is our other point of interest, and we see that -2 goes to 4. Our graph does appear to be correct.